The third area where we know that fatigue has profound impacts on human performance is around what's been referred to as simulation ability. If we go back to that original analogy around the chess game, situational awareness is the state of the board at this point in time. But in most tasks, as in chess, everybody's required to think about what am I doing now, where do I want to be, what are my particular options? And most people at most points in a task are calculating out what are the potential actions I could take, what are the consequences of that. So for example, in the game of chess, you might say, well, if I move my queen here or my bishop there, what will happen? And in most tasks, there is what we would call an iterative decision-making analysis. If I make this move, the system or the individual I'm playing against will make this move, in which case I'll do that move. And then you explore what has been referred to as the decision space. You look at all of the potential activities or choices that you could make, how you think that the system or the opponent will respond to those, and then you choose the one which you think optimizes the system in the long run. What we know as people become increasingly tired is that the extent to which they will explore the decision space shuts down. If we think about this by analogy in the chess game, playing chess against a child is a good way of thinking about how the fatigued brain works. If you've ever played chess against a child, you'll know that they only think one or two moves into the future. The same thing happens when somebody gets fatigued. They don't consider all of the potential moves that they could make, and they don't necessarily generate them far enough into the future in order to get a good handle on the total decision space that they're operating with. And there are a number of ways that brains do this that we understand quite well. The first of these is what we would refer to as frequency gambling. That is, in order to save bandwidth, the brain will make a decision to say, well, what usually happens in this situation? This is the reason, for example, why some people under the influence of fatigue are much more likely to make an error than others. If you have a lot of experience in a task and you understand what the normal probability distributions of the system are, for example, if you're a doctor, patients with this set of symptoms typically have this disease and typically don't have other diseases, then frequency gambling can be a useful heuristic that you can apply when you're fatigued in order to save bandwidth. On the other hand, if you're not experienced in a task, and your database for frequency gambling is not accurate, then sometimes frequency gambling can be based on what happened last time you saw this particular cluster of symptoms in the case of a doctor. It's very important to understand that when the brain tries to save bandwidth when it's tired, it engages in a series of reflex responses, and these aren't always accurate. The second area that we see impaired simulation ability is a reduced projection of options into the distance. So going back again to the chess analogy, how far forward do you think? How many moves in advance? And if you've ever played chess, you'll know that good chess players are thinking 3, 4, or even 5 moves ahead. Some of the best computer chess programs are thinking 8 or 9 moves in terms of exploring the decision space. But if you're playing with a child, they may only think 1 move in advance, sometimes not even that far. And again, by analogy, that's what happens when people become tired. They don't consider as many options and they don't project the consequences into the future nearly enough. This can carry profound implications for how well one performs a task, because in a sense, one may not know enough about the situation and one may have not thought deeply enough about the potential issues that may arise on the basis of what decision we do or don't make.